to everybody. So my name is Evstafev Dmitry. I'm testing engineer in a smart company, and I will tell you a little about the product. So our software product is complex and big. It's professional engineering system to produce e-copies of various articles and to prepare full testing documentation. So it's been developed for DOS, and so it's 30 years old. It, there is a lot of practical experience of its application, but of course we've been developing it, adding some functions, features. We are trying hard, doing our best, and several years ago we have completely changed the interface, and at the same time the company has developed a feature to record users' actions and then to reproduce them in automatic mode. We have accumulated around 4,000 autotests, and the number is growing constantly. So we needed to understand what is covered with the test and what is not. And we have had to develop a system to look for critical zones in software testing and like for the areas which are not covered. And there are a lot of options how to estimate the test coverage. One of these options is e-tables, like Excel, Google tables, or same. And like, you can list the tests, testing scenarios, some requirements, test status. But for big products with a lot of internal interconnections, tables are quite big and not very representative. The second option is using specialized special software, HP Quality Center, IBM Rational Test Manager, etc. They allow to control the testing process at all development stages. However, as the product is quite old, we have our own process and development schemes. And the third option is the graphical representation. We decided to go for that, and that's what we got. This is the model based on graphs theory. Naturally, the advantage of this model is that it's quite representative, visually clear, easy to build, it's accessible, but for a big product it's quite difficult. It takes a lot of efforts to build such a model, but you can do it step by step. I will tell you a little about the graphs, remind you what is that, because it's not included in all the curriculums. So you see these are the graphs, and the connection points are some events, and the connecting lines are the internal interconnections. We can use both options, oriented and non-oriented, for our models. The connection lines, there are some weighing factors. It's criticality in our case. It shows whether this functionality is critical or important or not. So the degree of criticality depends on how much it is connected with other product components or on how much it is used by the users. So we estimated with a score from 1 to 3. 3 is the highest criticality, and the criticality is assessment how much one function is connected with another function, or whether we can obtain the end result with this function. So then this function, which is the only possible basis for the second one, has the highest criticality, like 3. I will give you an example. So here we build a triangle, and as you see on the slide, in order to launch a triangle construction function, we can launch it from this control panel, where we have shapes menu. So in order to do that, we have to check the, we go to the main control panel, and then we go to rectangular shape. And the criticality here will be 3. Now we'll let's check the functions connected with the triangle. For example, the filling function. So we can do it through the context menu. So, but we have to understand that the model should include the hidden functionality, because some functions can come up only after some actions or connected with some events. Because if you click on panes and try to call the context menu, there will be no menu. So but when you construct rectangular shape, then we already can use this context menu. We have to remember about that. So let's use this. So we go to control panel, then rectangular, and then painting. So the connection between painting and the main panel will be 3, and it's quite theoretical, but we might think that from the main panel users go to painting more often than from the menu. Then that's why it will be, the criticality will be 2 between painting and the menu. So this is the result. So the most important thing is not to forget to make these connection lines and to define criticality for those. Now we start assessing the coverage. One of the options how to assess the coverage is on the screen. I will now explain you what it is. Let's imagine that we have to cover with test the most critical, most important functionality. The intermediate model has been built. We look at it, we select the connections with the highest criticality, and we have to cover those with the test at first. This is the highest priority. Because first we try this painting. If we use painting and the color of the shape changes, then it works well, and then we use mathematics. The first option is just to sum the criticalities. All the connections have their own criticality, then we find the total sum for all lines. Now here it's 52. This is the first example. In the second example, we calculate the sum of the functionality not covered with the tests. It's 32. And then, depending on what you prefer, like figures or percents, we can display it in like normal digits or in percents. So in the second example, the criticality is assessed based on the main functions. You see, like I marked it red on the diagram. So let's take the level with the highest criticality. So then we sum all the values containing 3, and now we get total, we get like 30. And then we sum all the values of all the connections which are not covered with the tests. And then we come to normal standard connections, nothing unusual. Here we look at the functionalities. So if it's not covered with the test, it's green. If it's covered, it's red. And then we calculate, like, for example, 22 non-covered, 11 covered, and then we find the final ratio. But this is not very representative, probably, because it doesn't show the criticality, precise criticality. So one of the advantages of this software is that we can do that in any graphic or block scheme editor, like Visio or graph editor or anything else. we can use any software for mind maps development. So almost any, except for those which not allow for setting criticalities for the connecting lines. As I have already mentioned, the product is very complex, very big, containing a lot of connections, and it was quite difficult to make analysis, make a model for the whole product at once. So that's why we did it step by step. So one of the components looked like that. So it's quite simple, as you see, but it only actually seems simple. But you have to understand that here you see what is white in the previous diagram. So here it's already consists of some components. So it's much more complex than it might seem at the first glance. So when constructing a model, we try to analyze some parts, some components of the software product at once, what is covered, what is not covered. But in any case, as soon as we constructed the model, we understood that only 62% of the product is covered with tests. We had to repair that, to change that, and that's how the model allows to see all the weak sides of the product and to cover those with tests. Of course, naturally, we started to cover the model with tests, and now you see we've got 75% covered, and we have more red blocks and less green ones, so it's quite representative now.
In the end, I'd like to tell you that such construction, such modal application very well demonstrates the weaknesses in your product, which or some functionalities that are not being tested. Also, it shows what you missed, and you can correct the situation. Such models are clear for testers and for developers because these models are based on the functionalities evident for the user. These models support communication among developers and testers, communication in the same language, and there are no misunderstandings. Another advantage is planning. Since the model reflects all the connections, you can plan the test suitable. You understand what is connected, what is linked. Something if you forgot, it just simply planned, and it's much easier to do the cost and time consumption analysis. And this model fits very well to trading specialists because it contains all the links, all the functionalities. That's it from my side, and thank you for your attention. If there are any questions, please ask. Well, we have only 5 minutes for your questions. I'm working on a product, and my product is 25 years, so I really liked your idea and your approach. What is the most efficient calculation for coverage? We're using the first one, which is depending on the criticality, on general criticality, because it gives more information, since the criticality level ranges from 1 to 3, and the maximum indicators affect final result more. That's why the first one is better. After that, everyone can choose what he or she wants. I'd like to add that I really liked your system. I'm working the same way, though I'm not using graphs. But thanks to such a system, it's very easy to understand the changes and what should be tested. Maybe some weights should be checked. You can check all the links, all the interrelations. I think you also understand this and you also like this. And you're right, this is important and essential. Now, let's choose somebody who will ask the question. I think this person is really willing to ask me something interesting. Your report is interesting, and here you have seen in the graph there are certain transitions. Have you ever thought of thinking to use the scenario based on a graph model? And have you ever thought about automating such a scenario? Well, actually, we were thinking how we could automate it because now we only have it in a manual mode. We are now experiencing and trying different automation approaches, and now we are thinking and considering which of the options will be easier, which will be more precise, which will be less time consuming. You see, it's really hard to automate something relating to such a product containing a lot of modules. I have a very small question, just specifically relating to the figures and numbers. Your project is very big. You have developed a very complex system. How much time did it take you to build the model? Was it really helpful and useful for further extension of the product by tests? And what will be the value of this? I like your question, it's a good one. Several persons from my company were developing this model. They are familiar with the system, and it took them a week, 1 week to build the whole model. It's not complicated. You only have to put the values and put the numbers. Thank you for your presentation. This is great. It's really nice to see that you have done so much work, and I would like to implement it in my company as well. Please tell me the following. Here, you only apply to the criticality indicator of the functionality, but when performing automation, you should also take into account the complexity. Because in the end, if you try to automate certain functionality, the output will be better if you envisage complexity. So do you take into account complexity? No, not yet. We are planning to do so. We are planning to include complexity in the model, but not at this time. We would not like this model to become more complicated, not too complicated. We would like it to remain clear. I think we will be able to discuss the remaining questions somewhere outside of this room. I have a question regarding the table at the end of your presentation where you show the presentation of the whole product. Does the program apply the color automatically, like red or green, or somebody does it in a manual mode after doing the test? All the blocks are interlinked with the automated tests, just via a simple link. There's a link to a test, that's it. As regards how we highlight it with color, this is done manually by one of their employees. We are now thinking how we could do it, but it's still quite problematic to implement this solution. We're searching for the options, for the opportunities. Maybe after a couple of months we'll be able to do it, and I'll come for you with another presentation sharing how we do it.
И поднимите руки, кто задавали вопросы, чтобы получить.
Вот девушке розовенькой. Спасибо большое за доклад.